I think I've got everything. Cool. It seemed really quick. The other guy left and I'm like supposed to start. Hi everyone, my name's Clifford Agius and I'm going to talk to you about a Bionic hand. As you can see down here, it's been on the Microsoft desk most of the day and it will be back there when I'm finished here as well. There's lots of bits down there. I know it's COVID and we don't all want to touch the same stuff, but if you want to come and play with it, then fill your boots. I'll leave it down here after the talk as well. But these are all the 3D printed parts that we've made in the process of making a hand for Kayden. I'll clean it all later. Wondering about this. You got to wonder, haven't you, about PowerPoint. I'd turn it off, but it'll probably take me longer to work that out. So we'll just have fun. And when you giggle, I know you're giggling at that and not at me. So a little bit about me. And this isn't me kind of having this slide in here because I want to show off. I'll explain why I talk about this. Anyone that knows me, follows me on Twitter. My Twitter handle's at the side of every slide, Clifford Agius. You can find me there. And talk about tech. And Xamarin IOT is the space I normally work in as a freelance developer. But I'm also an airline pilot. I fly for a major UK carrier. I fly the 787, so that's my office. I got back from Stockholm yesterday. It's odd that we do short haul on a 787, but not next week, week after I'm off to Seattle. So yeah, I get around the world. I'll come back to why I talk about being a pilot. As I say, it's not me showing off. There's a valid reason for that slide being there. When I'm not flying planes, I'm writing codes. I'm working with IOT, I'm working with Xamarin, or even Maui now as it's becoming known. I work with tech. I love teaching people, especially working in STEM subjects, working with schools and teaching in schools as well. If not, you'll find me out on a bike somewhere with the kids and doing some fun stuff. I'm not here to talk about me though, we're here to talk about Kayden. Kayden is a happy-go-lucky teenager. He's actually just started work, believe it or not, using Handy, which is awesome. We'll come to that later. But we started this project some years ago. Kayden's family, we've known for years. He went to school with my kids. And as you can see in the pictures there, he's got no left forearm. He was born like this, so he's got no arm, as you can see. If you look in the lower picture, his other hand is missing all the middle fingers, so he's got his pinky and his thumb. Yeah, or as he calls it, his crab. And you can just about make out there the claw that he's holding his hand in, which is actually this one here. So you can see there, this is Kayden. He's going off to the 2012 Paralympics. He was given a ticket to go after that. And you see that's his party trick. He clips his arm onto something and steps away. And you watch on the London Underground, everyone goes, oh, what the hell? You can see there though, in the lower picture, you can see the arm, he had that brown melamine plastic one, and then he moved on to the fiberglass one because he was starting to get a bit bigger and they trusted him not to break it. Fools. And he moved from the red one, which I got in my hands, to the green one, and then he moved on to a black one, and he went back to a red one, so he gets to pick the colour he wants. And you can see what happens is every year he goes back to the hospital. Every year he goes in there and they take a cast of his arm and they produce one of these, which is a cast of Kayden's arm, which is what fits inside there. It doesn't fit this one, it fits the green one. And it fits inside there. They then send this, once they've got the cast in plastic, they send it off to the lab. Lab technicians make a new arm. Okay, that process costs the NHS between £4,500 and £6,500. So not cheap. But that doesn't include the hook. The hook on the end, which detaches, that costs between £1,500 and £2,500. It's aluminium, so it's quite lightweight. Yeah, and he keeps that between hands, unless he breaks it. He's a kid, of course he's going to break it, which is why they make it of metal. This here is just bog standard fishing line you get in fish tackle shop. So the family have got reams of that, and they replace it quite happily. And the way he works this is, it's obviously too small for me, but that goes onto his arm, goes across the back of his shoulder, and he pulls by moving his shoulder in and out, and it opens and closes the hook. That's it. Imagine living your life, and that's all you've got. Not brilliant, is it? That there, I took when I went to the Imperial War Museum with my kids early last year. If you've got good eyesight from the back, you can read at the very top. It says December 1920. So over 100 years, we've got exactly the same technology. It's not good, is it? You know, all the things we can do with, you know, all the tech we've got, all of the, you know, the combined brains in this room and the tech we've got, and we've moved from that to, well, we're making it out of fiberglass instead of steel. So a little bit lighter. Yeah, we moved from a leather strap that might break in the rain to some fishing line. It's not brilliant, is it? This is Kayden, showing off how dexterous he is with his arm. I had to really beg him to go make me a cup of tea and do it on video. Being a teenager, they don't really like doing that sort of stuff. I won't move on much beyond that. He just carries on making me a cup of tea. It wasn't a very good cup of tea either. But you can see that he's quite dexterous. And the reason Kayden's really dexterous is because when he was born, his parents and his mum Sharon is, she's in the PTA, she's all over the community locally. When he was born, she was like, right, we need to help Kayden, we need to help our son, as any parent would. And she found out about a program with the hospital, NHS hospital trust locally, about the fact they was helping kids with limb deficiencies. And she got Kayden signed on. So from birth, literally from a toddler, and she showed me pictures, but she didn't really want me to share them in public, of Kayden kind of crawling around the floor, and he's got literally, it's just a lump of plastic that's formed and fits him. So from birth, from a few months old, all the way up to, now working in a kitchen at a local pub, he's had an arm. He's had an arm that actuates. So he's learned from a very early age that that's what you can do. So he's very, very good. We have tried one of these hands and arms on a child that hasn't had that, wasn't lucky enough to have that. They had a medical problem, it was meningitis, and they had to have a limb amputated. So we've tried this on them, and it took them a little while to get used to it, but they've gotten used to it, and now they've got a hand that moves. And we'll come on to that. So if we go across, and hopefully this works. There we go. So, yeah. Well, it wants to be on the other thingy, doesn't it? There we go. Oh, by the way, if you're here for Ryan's talk, this isn't Ryan's talk. I'm not Ryan. So if you hear about the, I forgot me giving a talk about now. I think it was mental health, wasn't it? Sadly, Ryan's not well, so I got kind of drafted in late yesterday. This here's the Limbless Association. When I originally spoke with Sharon, it's back in December 2016. I'm not sure if anyone remembers, but there was a news article in BBC, Sky News, etc., about a dad that 3D printed a prosthetic limb. And, someone come to school and she's like, Cliff, you seen the news? I was like, oh, yeah, I have. And she said, you got a 3D printer, haven't you, Cliff? I was like, yeah. I know where it's going. So I went and Googled and looked around, come across the Limbless Association. Now, I've been giving this talk for a couple of years now, until 6 months ago, and it took me by surprise because I'd looked at the website the day before. I then gave the talk online, and this page suddenly appeared. Up until then, this page that has all the links and etc., was still under construction. I mean, in this day and age, there's kind of web developer out there putting up about the fact that under construction. But it's now got a fantastic site with lots of bits and information on there for people. But it wasn't what we needed, wasn't what we were looking for. So I eventually found a news article and managed to follow the links and get through eventually to Team Unlimited. It's a wonderful team of people around the world now. It was just in the US and the UK, but it's now around the world. And they're 3D printing limbs for children, basically. And the reason they're doing it in 3D printing is because you can prototype it really quickly, you can build it. When they grow, you just print another part. It's dirt cheap, as you'll come to know in a little while. They've moved on to Isabella as their current edition. I've printed quite a few of these and taken with me on flights to deliver around the world. But this works, as you can see. I'm not sure if the laser will work. No, it does. You can see it's got a fishing line, and it works the same premise as this one. So you just pull, same thing, and it works the same premise, but the hand just grips. And that's all it can do, is grip. So we took their early design, it's moved on quite a bit since then, and we printed one for Kayden. And I managed to persuade the hospital to give me one of the spigots. We glued it onto there, done the fishing line, plugged it in, gave it to Kayden, and he played with it for a minute at most. I hate it, it's crap. Don't like it, Cliff. Fine, yeah. Any other feedback for me? Teenagers, eh? And the reason is because it closes, but and you know, you're more than welcome to come and play with this afterwards, but it grips, but it doesn't fully close. So you can't actually grab something other than like that. So he played with it and was like, no, firm hook. Like, oh, fine, I'll go back to the drawing board. Go and try harder. You know, we all love feedback like that, don't we? So for some reason, this page is blocked by the university. Don't know why. But this page would have been OpenBionics hand projects. And what I would be talking about is Joel Gibbard developed this robotic hand as a university project when he was at uni. He then moved on to turn it into a company, which is called OpenBionics. So this here is Tilly. She's one of their poster children. I've forgotten, I think it's Tyler is the boy. But Tilly's, if you watch Sky News at the weekend on Saturday, they have a kids version of Sky News on a Saturday morning. I think it's about 11 o'clock. Tilly is now one of the anchors on that Sky News channel. She's got 2 prosthetics. You can just make out the glow, the second one, her left arm there. She's got 2 of these from OpenBionics, and they're fantastic. The name OpenBionics is because they were open, and it was all on GitHub. This should have been playing as a movie, but I'm not sure if the internet is allowing it. But here is the GitHub repo. This is live on GitHub just now. Can anyone spot anything with that repo? I'm not sure if you can see it, but last 3 years. So 3 years ago, just when I was starting out, they stopped accepting PRs and stopped pushing to this repo. But they left it there, which was enough to work with. So I took those files, printed off hands, and that's what we got. And then it was a case of, well, how do I attach it to Kayden? How do we get the electronics to work? And we moved on from there. I used to, and I regret doing it now, but I used to really sort of, you know, take OpenBionics to task. How can you call yourself open if you're not really open anymore? You know, you've kind of locked it down. But actually, talking to a few people that you know them a little bit more than I do, they won't talk to me for some reason. They've now getting their arms approved with the NHS, or trying to. They're trying to get them into Germany and France, approved with their health services, and they're now approved in the US if you've got a lot of money or you've got a really good medical insurance. Their arms are being sold out there. So what they had to do is they couldn't be open. They had to go closed source because they needed to control what was there, because they needed to get it certified. Or that's what I've been told anyway. It's enough for me. I'm quite happy with that. They've left the design online and we can move from there. So we go back to the slides. Hey, so we search the web. So now we need to make something. Let's click somewhere. There you go. So we printed off all the parts. You can see all the white parts there. They're PLA, polylactic acid, which is a standard. Anyone here own a 3D printer? A few hands? Yeah, you know what PLA is, don't you? So that's just a bog standard PLA. It's really cheap stuff and you can prototype quite easily. The red bits you can see are a flexible filament, Filaflex 98A, if you want a technical name for it. And that is just flexible. And all that is holding all the parts together, and you can kind of see it in this hand here. It's all the flexible bits between the fingers, holding it all together. Then there's some springs and screws and dowels and stuff like that, and some at the top there them 2 bags of brass inserts. If you do any 3D printing and you need a machine screw thread, you're not really going to get it. You typically normally use a self-threading screw of some kind, like a wood screw or something like that. If you get these inserts, Inserts Direct I think is the name of the company, and you just put them on the end of a soldering iron, just push it slowly into the plastic and pop soldering iron out. It'll leave you a machine thread, a brass machine thread, and it stays in there and it's serrated around the edges. So they're absolutely amazing, and I found them for this project and I use them in all my 3D printing projects for all the stuff I do for clients. They're fantastic and they're dirt cheap. You just have to buy a bag of 1,000 at a time, but they're really cheap. So print all of these, and then in the top left there you can see the 4 motors. These are Actronics PQ12s, and all those little DC motor, and as you apply voltage it travels out 20 millimeters. You apply voltage in the opposite direction, it goes back in 20 millimeters. Simple as that. It's got an inbuilt potentiometer, so it gives you a positional resistance, so you can measure that with with the IoT board and work out where in that travel it is, so you can stop it, start it, do etc. So now we need to attach it to Kayden. So what we did, you can see my 3D printer working away there, is we took this, I gave it to my son, Macaulay, who's an absolute dab hand and amazing with Blender, and I said, could you do that in Blender? So, yeah, give it a go. A couple of days later we said, will that work? So we'll try. So we printed it off and we printed that part there. You can see there's 5 hours, 45 minutes left. This is on the Prusa printer. We tried it on my original Rat Mendel. It didn't work, so I upgraded to a Prusa because that's what you do. If it doesn't work, you buy the latest tech. So I upgraded to the Prusa, and this was one of the first prints to come off my Prusa, and I still hadn't got used to it and didn't think about the fact it would pop off the print bed. So in the left-hand way, you can see it popped off the print bed, and it's just gone to the windowsill behind the printer because there's 5 hours left. I went to bed, you know, I'm gonna go to sleep. It's just printing thin air, and that's why you get the spider's web. Every 3D printer's nightmare. But it printed, as you can see in the middle, just enough. So we cleaned up the edges where it popped off, and it was just enough to go and try and Kayden, and it was too small. So you increase the size, because you just do that, just say make it 10% bigger please, and it prints another one, and that's that one there, which is in the picture, drawn all over. That was just too big. So then obviously version 3, just like in the nursery rhymes and everything else, it fitted perfect. So this is Kayden wearing V3, and to hear me, the bit that made me really happy is the fact that he said this fits better than the one I get from the NHS. It fits like a glove. It's really, really nice. It's comfortable. It slipped off at first, so all we did was we put some a raised part just on the inside here, behind his elbow, and it stopped it slipping off. And that was like a simple change, and it no longer slips off. But yeah, that's V3. Yeah, pretty awesome. So now we've got all these parts that we've printed, so let's talk about how much they cost. Because like I said, this is £6,500 and have to replace that every year. Yeah, that's £2,500 and have to replace that every, well, however long it takes them to break it. They're a kid, they're gonna break it, aren't they? So you can see there, hopefully you can see this at the back. At the top is the moulds, and they come to £10. Now the moulds, you can see the top image there, and I've got them down here you can come and play with. These here, if you look at the hands, and this is the original one, the very first one. Look at that. The plastic is printed. The moulds, we tried 3D printing the finger pads, but it's just like Lego, it slips off. Yeah. So what OpenBionics designed in their hand was the fact that you use this mould and you print that, and then you form this, and it's out of a neoprene rubber kind of stuff. I've forgotten what it's called now. Anyway, but yeah, it's fairly cheap. They use it to make masks. So if you watch any of the movies and they make the mask of, like, you know, a Klingon or something like that, it's made of the same stuff as that. So all you do is you fill up you screw the part in. So this here is for the palm, the bit in the centre. You screw it in there, fill the reservoir with liquid, squash it down until it starts bubbling out of the holes, and leave it on the side for 16 to 24 hours. And then you unscrew it, just clean up around the edges. Job's a good one. That's £10 for the complete set that you need. I've built about 15 of these now, and I'm still on the same set. So there's one set of moulds, and you just keep going. The actual hands, the middle section, you can see comes to £4.93 in plastic. It's gone up slightly. I'd say it's probably about £5.10 now. But you buy a spool of filament, and it costs £21 for a spool of filament for PLA, and I can make 4 out of one spool. So, you know, not expensive, is it? So that's kind of replacing that. That's socket that we put onto Kayden. He sends me a message about every 9 months now and says, oh, it's starting to get a bit tight, Cliff, can you make me a new one? It's a 6.5 hour print. It costs 80 pence, $1. Yeah, and I don't even bother, you know, because obviously COVID last year, I just dropped it on his door, and his dad changed it out for him. You know, a couple of screws, a couple of wires to connect, job done, and he's now carrying on. So yeah, 80 pence. The central arm section, this bit here, yeah, is about 90 pence. And all we've done there is made it such that the battery, where the battery's gone, it's here somewhere. I hope I can find the battery, because otherwise you won't see it moving. Oh, there we go. The battery just slots inside. And this here is just a normal Anchor power brick, 10,000 milliamp hour power brick, that you literally bought from Amazon. And the hardest problem we had was persuading Kayden and his friends not to charge their phones with it because he wants to use his arm. But yeah, go to school and he's like, oh, I need to charge my phone. It's like, yeah. So, but I wanted to use bog standard off the shelf parts. If I couldn't buy it from Amazon, yeah, or a local hardware store, I didn't want it in the project. And I'll come to why a bit later. But one of the, yeah, so the arm is, you know, 90 pence, so just over $1. That's kind of 80 pence. That goes in there. This one doesn't because it's not the right size, but the black one will. Goes in, and then that's the arm, and then the hand fits on the end. I've just got bench holders here for the hands, and the black one, which is here, is exactly the same as the white one, but just doesn't have the electronics and motors. And the reason I've got the two is you can feel the weight if you want to come and play with it afterwards. So we've got that. Leave that there. So this is handy moving. So you can see it there. It's moving. How cool is that? Yeah. So it's, yeah, everything's okay. We're good to go. Let's talk about what is inside it. What controls it? OpenBionics at the time had a board. It's still on GitHub, the chestnut board. You can go and download it and get one printed. Good luck. You go out to a fab shop and get one made, but unless you want to make tens or hundreds of them, it's going to cost you a lot of money. They had a store at the time, an online store on their website for the developers, when they were still accepting PRs, etc. from the community. I waited 2 months, 3 months, still couldn't get one. They were £250 plus postage and packing, plus VAT. So you took the best part of £300 to buy a board. I thought to myself, well, if I'm waiting a few months, we're going to put this in the back of our hand, give it to a kid. What are they going to do? They're going to drop it in water or a puddle. They're going to smash it in the playground. Something's going to happen. And then they're going to be without an arm or a hand for a while. So on the OpenBionics program, they could call them up and order a new one because OpenBionics were keeping them back from there. But OpenBionics were charging 10 to 15,000 for an arm. Now that did include all the support, it did include the doctor's involvement, the prosthetic surgeons, etc., to size it correctly, etc., etc. But it's a lot of money for some families to afford. The NHS weren't providing, so I was like, okay, fine. And I'm thinking in the back of my head now, actually, you know what, let's see if we can get this really cheap. Let's see if we can make this so cheap we can give it to countries that don't have the fabulous NHS that we have. So how do we control it? So that's just if I go back a sec, that's just an Arduino compatible board. Yeah, so it's got an Arduino ID compatible. It's just a Atmel ARM M0 Plus. So it's a fairly bog standard chip that's used in IoT. How do we control it though? Well, they use these Maiware sensors, or they were. They've moved across these other ones now. And I did have one here earlier, but you can see the picture anyway. So you got two, the red board, each end of those got two sticky pads. If you've been and had an ECG or an EEG or whatever at your doctor's, they stick the sticky pads on you, don't they? That's just them. And the little fly lead goes off and it has to go on, it's called the myotendon junction, so somewhere where there isn't muscle, so typically the elbow. And that's just so it's got a null reference, something to reference against. But you need two of those. They're £35 each, so £70. You're going to stick this on a kid, like literally stick it on them. They're going to break it. You give it half a day, it'd be done by playtime. You know, it'd be broken, won't it? The sticky pads, you need 6 of them per day because you need to change them. You're not going to stick them back on the following day, are you? A pack of 50 costs £5, which doesn't seem a lot. But a pack of 50 is going to last you, a week. So that's a cost now to a family going forward. You know, parts of the world I'm thinking to take this to, that's a cost that is a cost too much. So I'm thinking, well, I don't quite like this, but let's, we'll go with it for now. We'll tell Kayden to be careful. Yeah, that worked. I've got all the broken ones in here. But how does it work? Well, you can see here, this is the muscle with the Doctor.NET bot. The green one in the center is the correct placement. It has to be center of the muscle mass. Now for Kayden, because he's got no arm, his muscles are 90 degrees out for us. As the front and back, his are literally right at the front and right at the very back because he's got nothing to tender the other end to. If you're off slightly to the sides, you get the midline offset, and slightly above, you get midline offset, there's no signal. Intervention zone is in the center but off to the sides, and then the myotendon is where you put that little fly lead that I mentioned, which is at the end of the muscle. So you have to place it correctly as well. So you have to stick it on the child in exactly the right place, which isn't ideal, is it? And they'll move it, and then the art won't work. It's like, oh, I don't like this. Let's talk about how it works. Right, this is audience participation time. I want you all to hold an arm up, doesn't matter which one, just come on. I want someone to get a picture of this as well, yeah? If you'll get your pincers on the other hand and hold them either sides, this is good. Now if you do the open, which is hand away, you'll notice that the muscle at the back of your arm goes tight. If you close towards you, the muscle at the front of your arm goes tight. If you hold your hand up and make a fist, both muscles go tight. So now we've got open, we've got close, and we've got the fist, which is change to the next grip in the grip sequence. How cool is the human body? Yeah, how good is that? It's given us the signals we need. So these are the grips that OpenBionics come up with initially. So fist, grip, palm, tripod, point gesture. Yeah, so now he's got 5 grips. You had one before, you could just grip stuff. Now he's got 5 grips. How cool is that? You know, made his life so much better. But how would you like to work and live your life with just 5 grips? Your hand can only do 5 things. That's it, nothing else. That's all you got. Yeah. How about holding your Xbox controller? Because he wanted to play games with his friends. Yeah. How about, as he asked, telling his teacher, sorry miss, the battery's gone flat, where he gives her the bird. Teenagers, hey, you know? He actually asked for that. It was, yeah, I was like, I'm not sure your parents will let me do that. But hey, but I wanted to say to him, you know what, Kayden? Here's your mobile phone. You go and make your own grip. You do what you want to. You do you, yeah? And then the next child's come along and they want a different grip because they want to do something different, yeah? You do you. You sort it out yourself. So again, it's another thing I wanted to do. We're all developers, or most of us are developers here, yeah? If I was to say to you, this is, you know, Arduino C, you'd be like, oh, what, C? Not C sharp or you know, Kotlin or whatever, you know. But yeah, you could work it out, yeah? If I zoom in, yeah, it's very simple. It's a 3D array. On the left-hand side is a counter that counts from 0 to 100, yeah? And we have a timer in the chip that just counts up from 0 to 100 over a period of time. Kayden, we worked out about 1.6 seconds was about right for him. Others are either less or higher, how quickly they want it to move. So 1.6 seconds, it counts from 0 to 100. And then you look along the top line, and we take thumbs. You can see the thumb, F0 is the thumb, is fully open. All the others go fully closed. So they start moving instantly, that grip is actuated. Yeah. And then the thumb goes fully closed as well, so it comes across to make a fist grip. It's misnamed in their code base. But that there, if I then said to you, go and make an Xbox grip, yeah, to hold an Xbox controller, or go and make a grip to hold the guitar, the fret of a guitar. I did get that right, didn't I, Dylan? Yeah, good. You'd be like, yeah, I can do that. Yeah, I'm a developer. Yeah, you crack open VS Code, you crack open the god-awful Arduino IDE, and you actually, the new beta 2 version is much better, but the original version is, Notepad is better. And you're like, I can do this, you crack your knuckles, you sit down, a couple of hours later you come out with your design that's working. But in that, you've had to install the Arduino IDE, you've had to install all the tool chains to talk to the boards, yeah? You've had to get the right cable out because it's a, you know, a USB cable that isn't USB-C, and you're like looking around for the old cable. You've had to write the code, compile it, take the board out the back of the hand, push the code down to the board, put the board back in, test it all. You've done that 3 or 4 times because you're iterating on your design. It's fine, we're developers, we can do that, yeah? We can wield a screwdriver and work that out. What if you're a technician in a hospital? What if you're a parent? What if you're a child and you want that grip because you want to, you know, impress your friends or something? Look what I can do. It's not so easy, is it? You know, you could probably teach them, but if it's a young child, like 6, 7, 8 years old, it's not going to work. So again, something else I'm ticking in the back of my mind. I don't like this. It makes me feel bad. So drawbacks, we talked about the board single source supplier. They now don't sell them, so thankfully I didn't go that route because you can't buy them. Talked about the muscle signal. The other thing I didn't mention is the MyOS sensors has got a little potentiometer, gain potentiometer, which as the muscle grows in strength, you have to tweak the grain down. And obviously, Kayden hadn't been using his muscles for 14 years, and he suddenly started using them. They're starting to get stronger again. So you know, we have to keep tweaking it down. The grips sequence. You got 5 grips. Remember I said you fist grip and you hold it for 600 milliseconds is what Kayden's got you set at. You fist grip, right now on the, what one am I on? Oh, I can't remember. Right, okay, I'll actuate it. Oh, okay, it's the point grip. So I need to go 3, right, I'm at the grip that I want to hold the carrier bags, you know, to grumbly help parents with shopping. And if you want your own personal grip, because you want to play Xbox with his friends, I use Adafruit. Who's heard of Adafruit? Hopefully lots of people. They're cool, aren't they? Yeah, come out of New York City, Lady Ada. It's fantastic. If you want to get into IoT, you go to that and you'll spend a lot of money. I think they've got a direct debit straight into my bank account now. Them and Pimeroni. This board here is less than £30. The red section at the bottom is, that's Bluetooth. That's cool. It's got the same Atmel chip that the OpenBionics chip had. And we've got a JTS plug at the top, that black plug, which is for charging the battery as well. That's good as well. And it's got all the other bits and bobs we need, all the analog inputs we need for less than £30. That's a winner here. That's the board, soldered onto, I was prototyping it, so soldered onto a daughter board underneath, just so I could get all the traces in the right place. And the board just above it with the big red and black spiral cable out, that is a DC motor controller board, also from Adafruit, also I think that's about £20 or £25, we'll see later. And that was it, fantastic, how cool is that? So we're now talking £60 as opposed to £250 plus postage, packing and everything else. And you can buy these from Amazon. And them boards did come from Amazon, cost a few pennies more, because you know Jeff Bezos needs to fly to nearly space. Nearly, close but no cigar. The biggest problem I had, as you can see in the right hand picture, is their through-hole pinouts on the boards, and the ribbon cable that comes out the back of the Actuonics motor is a flat ribbon cable, FPC. I need to connect them together. So it took a little while, how am I going to do this? But I managed to find a connector, which you'll see later on, which fitted that. I got them from Amazon as well, just to prove the point. And there was like pennies for a pack of like 50, I think it was. Sold them on, and yeah, all is good. But how about this myaware sensor that I mentioned? You know, how are we going to sense this muscle? I remember specifically this flight because of this magazine. I read it a lot. And in fact, that one is just there. This Hackspace Magazine, if you ever want to get into IoT and hacking with electronics and playing with things, build your own funky guitar where you dance on the floor, and you know, all sorts of weird and wonderful stuff is in this magazine. It's brilliant. Highly recommend it. I've been a subscriber since issue, I think, 2 or 3. Flying along, Graham Morrison had written this article about Arduino debugging. And I was like, yeah. Anyone that's done Arduino, has anyone done Arduino stuff in here? There's a few hands. It's painful, isn't it? Yeah, lots of sleepless nights. I was reading this article and I was like, well, what's he doing? What tricks has he got? Because as developers, you want to learn from your peers. What tricks has he got? He's got a piezoelectric sensor in the bottom corner there, that little brass disc with a couple of wires hanging off there. I was like, oh, what's that? You know, I heard of a piezoelectric buzzer. We've all got them in our computers, you know, buzzes 4 times for memory or whatever it is when you turn your PC on. So all that is with a piezoelectric sounder or buzzer, you supply an electrical current and it buzzes. The crystal vibrates and it buzzes. This one, you make the crystal vibrate by thumping it, and it provides a voltage output. It's only millivolts, but enough to measure. So that's all he's got. He's got an Arduino Uno plugged in there, and he's just literally thumping it. And then in his code, debugging what's going on. So I bought a pack of 10 of these for £1 from Amazon. As soon as I landed in Japan, I was flying across Russia, landed in Japan, I was like, these are so cool. I was literally on the bus, ordering them to the hotel, and they beat me to my house. So I'm not sure where in the world they come from, but they beat me there. And I installed this in the arm, just inside the socket. You can see these ones are the ones we moved to, but just glued them on the inside with some glue and caps and tape, wired them up, gave it to Kayden. He was like, oh, they're much better. But I now can't stop the grip, mid-grip. I can only close it open. And the reason was I had to change the code, because you only get a millivoltage output when it's been thumped, and only for a few milliseconds. I couldn't say, okay, we're roughly there, let's stop. It was like, activate the grip or don't activate the grip, and that was it. So I was like, oh, okay, we're on to something here. We've got something that he prefers, rather than the sticky on things. So I then went back to my lair and searched in Sparkfun, another great place for IoT stuff. You can see here, force sensitive resistor. You can see in the GIF, whatever side of the fence you sit on. As you apply pressure, it gives you a voltage output which is linear because it's just a resistor. So we wired that up and that is literally what Kayden's got now. In here, in this one, you'll see it's just glued on the inside with some Kapton tape. In Kayden's one, they're actually fitted inside a lot neater and nicer. So now we can control it. We've got rid of these like two 35-pound boards, the MyAware ones, and all the sticky pads. So that's the ongoing cost. We've now got these two, which cost £6 for a pack of two. We're onto a winner now. We're really getting this price down, driving it down from the thousands that the NHS pay. The NHS, if you want a fully electrical one with all the moving bits and bobs in it, they're in the £100,000 range. And you only get that if you can prove that I need it because I'm a sports star, or I need it because of my job, or whatever it is. You need to really put a compelling case forward. No child's ever going to get it because every year they need to have a new one. So we're on to a winner. We've got that going. So now we've crossed off the control board, we've crossed off the weak muscles. What about this grip sequence? Yeah. As I mentioned, I'm a freelance .NET developer. I work in IoT and mobile and Xamarin space. So I was like, well, I write Xamarin stuff for clients. Let's give this a go. It's .NET, so C#. So if you've not played with Xamarin, or Maui as it is soon to be named, not November, sadly, the team have now pushed it back to Q2 of 22 for valid reasons, and I applaud the team for standing up to the .NET team and saying, actually, we're not ready for .NET Conf in November, we're pushing it back. But it means with Xamarin, it's a full native app. So if you build for Android, iOS, once it's built, it's native. It's not something else. You got access to the Bluetooth stack. In Xamarin, it's not part of the Xamarin stack. You end up using a package called Shiny to make it work. Alan Richards, I think his name is, or Richie. He's a Canadian guy who's written the Bluetooth thing, and it's so good that Xamarin are just go and use that. Which I think is really cool of the team to say, well, there's an open source project, go and use that one over there. Be really cool if they gave him some money. But hey ho. And the other thing is, because it's native, Kayden, when he uses his phone, because he's, that hand, even with handy, isn't going to be able to pause the screen because it's not got a way of sensing on the screen on his Android phone. But his other fingers, he wants to pause the screen. So he has the button slightly bigger and the text slightly bigger and things like this because they're his needs. Because it's native, he just turns on the accessibility settings and he sets everything a bit bigger. Android and iOS. Under Xamarin, it wasn't brilliant, but it did it. Xamarin Forms 5, it's a lot better. Maui, they've really gone to town with accessibility. So it's getting really good. So if we plug in handy, where's it gone? Here it is. And we plug in my phone, which is here. I did mean to have this set up earlier, I promise. Right, let's set up. Right, where's the mouse gone? Let me just do that one. I kind of need my mouse, it's disappeared, there it is. The other way. There we go. It says, there's my phone. That's my family, wife, boys, dogs. So if I open the Handy app, there we go. There's Handy app opening. You can see there, it's not connected. It wants a Bluetooth connection, so it wants to find the hands. So if I plug in the battery, so it's just that anchor power brick, and we click OK. We then see it will start to scan. You see, hand disappeared. We tap on that. Then because I've got a dev version of the app, I then do a lot of background stuff that I use when I'm planning and developing with it. So it's going to connect up to... No! Oh, come on, really? Right, let's try that again. Demo gods are not with me. Yes, allow, always allow from this computer. You should know that already. Where's the, oh, it's doing it now. Oh, there you go. Right, so this is just UART, which is a serial protocol. It's just sending, like, literally serial between the hands, the Bluetooth controller in the hands, and my phone. But if I lock this so that the children can't play with it because they can damage things. But if we go back to the grip selection, this is literally, so if I tap the button, that's handy moving. So it's the fist grip. There's the hook. There's a point. It's over there, my friend. Yeah, and you can see I'm going through these quite quickly. See at the top, there's little hearts where you can heart them and say that's my favourite grip. We go to the grip order. You know, remember I was saying you can't remember which grip is in which kind of where it is? Well, maybe you want a grip selection pack, which is just for school. So you only really need the one for the teacher. Need that there, yeah? And the pinch grip, which is to hold the pencil. Yeah, doesn't need any others because he's not going to tell his friends where to go. So he might want to reorder them. So literally, this is the sort of thing you can do. I want to put them in that order. Click save, and it'll save it down to handy. Yeah. But if he wants to make his own grip, there's a grip builder here. We can move the sliders around, move the fingers, and then add it and save it. You can build up your grip sequence. Remember I said it's 0 to 100. You add them up and build your grip sequence. So then you can have your Xbox controller, you know, the grip to hold the fret, that sort of thing. In the Bluetooth connection, you see a minute ago, sorry, in the settings, we can change the timings. So you can see there at the top is the left hand. Yeah, maybe they've got a right hand. So now I'm thinking in these settings that a technician in a hospital, a doctor, a parent can set these settings for them. You can set the hold time, which is how long you have to hold the fist grip to go to the next grip and grip sequence. Kayden seems to like 600 milliseconds. He wants to grip it really quick. When he's playing his Xbox controller, he drops that down to about 200, 250 milliseconds. So he's got a grip that goes to hold the Xbox, and then he changes it on his phone because he obviously can't create a fist with it. And then he then has it such that the finger position's there, and he twitches his muscles, and it just does the trigger in Call of Duty or whatever game he's playing. And he can shoot quicker than his friends. And the other advantage is he doesn't get muscle fatigue. So he's blasting away all his mates. Oh, Kayden, you're fair. Peak threshold is how much the muscle needs to be tensed above that threshold. It will then trigger the program sequence. You can turn the motors on and off. You can change the muscle mode from simple to complex, and that's just a configuration setting within the board as well. And then you've also got a muscle sensor check. And what we do here, you've got left and right, which is two muscle sensors, so open, closed. And what we do is we ask Kayden to open, close, fist grip, open, close, fist grip. Yeah, we ask him to do that 20 times. Those sliders go up and down as a muscle sensor, gives him a bit of feedback that he's actually tracking the data. And we send for processing, we send it up to an Azure function. It then gets put into storage on Azure. And the idea is, when I get around to it, that we'll then reason over that machine learning, and from that we can then decide actually that setting you've got 600 milliseconds really should be this. That setting you've got, there's other settings behind the scenes that we don't show in the settings page about how quickly the motors will move, how much gains take off the muscles, etc. We can then reason over it, send it back to the phone. Next time the phone connects to Handy, it will then say, actually, these are new settings, and plug them in. At the moment, I do it via that UART connection that I showed you earlier, that serial screen. What are you binging about now? You know what? I'm going back to the slides. Little fun thing, not sure if you can hear this. Can you hear the whining? Yeah? The motors, when you have a voltage applied to them, yeah, because you need a voltage applied to them to get the resistive sensor, so if it stops midway, yeah. If I tune it out of our audible range, yeah, my dogs go bonkers, yeah, because they're like, what the hell? So I tune it back into my audible range just to keep the dogs happy, yeah. And it's only because I'm using a test one. On Kayden's one, when the grip finishes, the motors turn off and then we turn it back on again. But because I do lots of funky stuff on the bench and it talks like this, I leave it running. In fact, I'll just kill it. And again, if you want to come and play with it later, you're more than welcome. If there's someone talking after this, you can come and find me on the Microsoft stand. This is Kayden with his Xbox grip. How cool is that? Kind of good, isn't it? If you're wondering why he picked the black PLA, you'll see there's a copy of his hand down here. This one doesn't have motors, so you can feel the weight difference between the two. No motors, no controls, it's just 3D printed parts. He said, I don't want it to be people staring at me and saying, is that fake? I'm not sure. He wants it to be absolutely obvious. So I said, well, this is where I get the plastic from. 3 boots, pick one. And he picked off the Prusa website, this Galaxy Black. You can just kind of make out in the pictures flecks of silver in there as well. And he picked the green, because he thought it went really nice. I think it's really impressive colour scheme he's got. You can see the old one behind on the bench. So let's talk about price. Remember we talked about 6,500, 4.5, 6.5, 1,500, 2,500. So that's part of 10 grand, isn't it? Yeah? £500. That's all 3D printed, all the motors. I can build one of these in about 2.5, 3 hours now, loading all the code and everything. I've done quite a few of them. So you can imagine if I went somewhere and taught the technicians in a hospital how to build it and put it together and program it and set up the mobile app, they can be building them for £500. The most expensive part, as you can see, the bottom line, the 4 Actuonics motors. Yeah, they're more than that now because they come from the US and the dollar rate has moved since I put this slide together. So my aim is to try and get this as low as possible. I've got some motors that arrived about a week ago, which are looking quite promising to do it. They don't move quite as quick as the Actuonics ones, so it's a little bit slower motion, but yeah, they're there or thereabouts, and they're about 25, 26 pounds. So I can drop that price considerably, and hoping to do that in the coming weeks and months. And again, you can see we've got the force sensitive resist at the top, the Actuonics motors, talking out to a Xamarin app, and going to move that across to Maui when it's a little bit more stable than it is at the moment. Has anyone here used Xamarin? Show of arms. Yeah, there's a few people. Yeah, anyone tried Maui yet? I know you have. Yeah, not many. Yeah, give it a try. It's really good. If you're installing it, use VS 2022 Preview 4 and onwards. You're golden. It sorts you out. What's next though? Continue building the Xamarin mobile app. The machine learning bit. Go full .NET. What do I mean by that? Has anyone heard of Wilderness Labs? No? The Meta F7? I've got one here, I promise. It's in there somewhere. Ah, there it is. Wilderness Labs, a little board, exactly the same form factor, exactly the same pinout actually, than the Adafruit board I've got there. It's ever so slightly longer, because it's got a ESP32 chip on the ends, which is allowing it to do over-the-air updates. That's cool, over-the-air updates. That's full .NET, it's running mono, so it's very similar to, in fact, actually Brian Contas, the developer of this, and the guy behind it was on the Xamarin team. I probably butchered his surname, but sorry. So yeah, we're going to go full .NET. Then we can do over-the-air updates into Handy. We don't need to plug a cable in and stuff like this. We can sort out the code in there. And also, it's exactly the same form factor and everything else. We started working on Leggy, which is the leg. Handy seemed to stuck on Twitter, so I called it Handy. Leggy is just the leg prosthetic, and it's very interesting how the human body transfers weight. If you think about it next time you're walking along, when you walk out here, just think about what your feet are doing, how they're moving, how the weight transfer goes through the foot, and how you need to position the motors to get the foot to flip back to where it needs to be. It's quite complex. The hand I thought was, going to be harder, but actually the foot movement is, very hard. But yeah, we started working on that and 3D printing parts from that. And again, I only want off-the-shelf parts, so that's a fun thing to work on. There's the Meta F7 boards. I didn't need to find it because I've got a slide for it, Cliff. And yeah, you can get those and all those. There's a V2's just come out. And the reason I hadn't put this board into Handy until recently was because until Beta 5, which came out about a month ago, 6 weeks ago, it didn't have Bluetooth. The Bluetooth stack wasn't working properly. They've now fixed it, so I can now get it working. Now back to why I mentioned me a pilot. Those that are very astute amongst you will realise through this I've talked about a doctor, a technician, a parent. Yeah, dropping these off around the world. I've mentioned being a pilot because I had a unique kind of thing of being technical and flying around the world and building these. That my plan is, and I've got a second Prusa printer at home, a Prusa Mark III i3, loves the threes for some reason, and my 10-year-old son built that printer. You can find it on my YouTube channel. You can watch him building it on our time lapse. He built it 2 years ago. He was 10 at the time. And he built it with no help from me. When you see me coming on camera, it's because I'm checking that he's done a few bits around the hot end correctly, because otherwise it breaks. Those printers have dropped in price now to just £600. And my plan is was last year, and something happened, I'm not sure what it was to put that printer, a couple of spools of filament in there from Prusa, the nuts, the bolts, the screws, etc. Put it all in a box and take it to one of the destinations that I fly to. And one of the hospitals I was speaking to one in India, I was speaking to one in Pakistan, one down in Johannesburg. You know, I was going to take it down and give them the box. I'm like, there you go, there's the box, this is how you do it, here's the GitHub, here's the code, this is how you print it. And then work with my company. And so I need to go back there in a couple of weeks' time again, and you know, swap rosters with friends to go back and work with them until they got it perfected and they could print it and make these hands for the children locally without my help. Yeah, that box I worked out was going to cost about £1,000 to £1,200 for all the bits I needed, without the motors, but all the other bits and bobs that we needed. And then all I needed was the motors and the controller boards. Everything else was going to be in the box. So that's why I mentioned being a pilot, and I bring it back to that. It's still my dream. The printer's still sat at home, and hopefully we'll start flying to these parts of the world and I'll be allowed to go and see these doctors. If you're aware of anywhere in the world that you know of, or any children or even adults that could benefit from hands, again, I'm on Twitter, my handle's on the side. Reach out to me and we'll see if we can help you. If you want to help, there's the GitHub repo, that's the app, the Xamarin App. There's a private version of this app as well, which is what's on the family's phones, and the reason I keep it separate is because we had to put some identifiable information in there for the data that's being sent up to the cloud, and we got permission with the family to do that, and I didn't want it to be on a GitHub repo because I was scared I'd accidentally commit it, and so I made it separate for now until we do that. And then what I'm going to do is bring it all back into the main app, which is here, and then blow the other one away and delete it. Hopefully do that in the next month or so. But you can jump in there. It's got all the STL files, the 3D printed bits. It's got all the electronics, fritzing diagrams, all the other bits and bobs. So you can actually go and make one of these yourself and have it moving around your bench. I'm not sure, someone mentioned, I'm not sure I did in the room, talked about having it as as part of their DevOps cycle. So okay, if everything's okay. And then all sorts of other finger motions for it's all gone horribly wrong. Instead of just that red lamp that glows on the end of the desk when the build fails. I thought it was quite a cool project. So was that the person that mentioned it? They're in the room? Yeah, there he is, yeah. So I think that's cool. I think we should talk about that. Come up with some DevOps thing to plug in. And last of all, I just want to say thanks to Kayden, his family. Without Kayden and his family, Sharon and Paul, I couldn't have done this project. We couldn't have helped the other families that we've helped along the way. Especially to Kayden, because his brutal feedback, and I'm telling you, it was absolutely brutal, was needed. He needed, to kick me where it hurts and say, look, Cliff, that doesn't work. I don't like this. Without him, we would have made it for another child that hadn't had the luxury of having one of these NHS arms, and they would have just been, yeah, it works, it's good enough. So, but because he had it, he could give that nuanced feedback. I think I've got a couple of minutes left. If there's any questions, if you want to come down and play with the bits, you're more than welcome. If you're wondering what it was that holds all the things together and pulls from the motors, it's just braided fishing line, £7 from Amazon, and I built 15 of these. I'm still on the same spool. So, I'm getting this stuff super, super cheap. But that's it. Any questions? Yeah, go on.
Kind of drawn comparisons to the prices that the NHS pay for their product, but
yep.
It seems considerably worse. Is this is it even an option to try and get this into something that the NHS try to use, or is it just? I've
left that to OpenBionics. Their version of this is more tailored to each child, and they're working with the NHS. I don't want to step on their toes. If it wasn't for them, I wouldn't have the design of the hands. The rest of it, from the wrist onwards, we designed. All the electronics we did. But without their initial idea, I don't want to step on their toes. They're an awesome company. They've come up with lots of great products and development around it. My only wish is the fact that their new version that they've got, their new version of the Bruno hand, they kind of give back to the community as well. But hey, that's me. But yeah, it's, if the NHS want to come and talk to me, they can find me, but I'll leave that to OpenBionics. I don't think it's fair for me to step on their toes. But yeah, any other questions?
You said about the cost of the NHS one. Why are they so much more expensive when you can go along for £100?
Because they've got a lab technician needs to first make that part, and a lab technician needs to fiberglass, do that, the materials, you know, the doctors backwards and forwards, and it's just the average cost.
Took like salaries and stuff like that as opposed to...
I assume so, yeah, on top of raw materials and things like this. You know, the raw materials has got to be a fair bit of money. All the lab equipment, the specialist lab equipment I need for making these parts, you know, it's not cheap. What we've been looking at and we've been trialing is, as part of the mobile app, is taking a bunch of pictures of the limb that's there, and then using a process called photogrammetry, where you can run that through a bit of photogrammetry software, and it will give you a 3D rendering back. And then we use that to create the moulds, and that will go straight into Blender, and then the moulds will be created. So, but even so, the cost, the raw component costs, is, you know, considerably less. So, I think I've got time for maybe one more question. I suppose I'll get out of here because I don't know who's talking next. One more, go on.
Where do you run the 3D printer? Because do you have problems with sort of smell, chemicals and stuff like that?
No, I print in PLA or PETG mainly. This is all printed in PLA, and it's made of vegetable oil, so it's, yeah, there's no smells. It runs out of my workshop, which is at the end of my garden, but otherwise, yeah, there's, I've got some fans that extract away the heat more than anything else. But yeah, there's no, if you print with something like ABS, that's quite a toxic fume, it's quite a strong smell. When I do that, I open the windows in the workshop and just, like, you know, make sure the kids and dogs don't go in there. But yeah, it's, you know, kind of cool. I even printed, it's in my box, don't know why it's in there, but for the NHS last year, we printed a load of face shields that Bruce had designed. I printed nearly 400 for the NHS, and we printed these masks. And all it does is, the blue masks, you know, the ones that we all wear, the fabric ones, you just cut a square out of it and click it in there, and then you've got a mask, and you can make that one mask, it will go on, you can get it to work 8 times if you just cut a square out. And we 3D print those for the local NHS doctors and nurses that were having to go out to the elderly and visit them, and they were just using that. And then when they got back at the end of the day, they dropped it in a bucket of Milton, which we all know for cleaning up the kids' bottles, got up in the morning, washed it under the sink and went back to work again. And that was when, you know, at the time I was flying off to China to bring about 80 tons of cargo from China of masks and PPE and stuff like this. But yeah, we printed a bunch of those as well. But the things you can do with a 3D printer, and it's £600. Yeah, pretty impressive. I think that's me. Unless anyone's got burning questions, you can find me, reach out to me on Twitter. Otherwise, thank you very much.